All right, so looking at using the Arrhenius equation for the problem, all right? I know, here, I'm gonna mute y'all because someone's loud. Okay, I know that I'm required to take the natural log of the two different rate constants, all right? So looking at that problem that we were pulling from, it looks like the very first rate constant that's given is the 6.42 E -5, and that's going to be over the other K that's given, the K2, the second one listed, of 2.03 E -1. All right? The whole problem wants me to find activation energy, which again, just following the Arrhenius equation, says that it's X over R, or it says AE, which is activation energy, over R, which is a constant value of 8.314. This is supposed to then be multiplied by 1 over the temperature minus 1 over the temperature, but it's T2 minus T1. So you've got to look at the connection there because this was K2. So you want to use the temperature connected to that variable and make sure that your values are lining up. And you can stop me, by the way, if anything is weird here. All right. So in other words, I'm going to put 1 over 351 minus 1 over 283. Now, these two numbers are not the numbers in the problem for temperature, because in the problem, the temperature is given in degrees Celsius, all right? It's given as 78 degrees Celsius and 10 degrees Celsius. So I've added 273 to those, right? If one of them was 10 degrees, 10 plus 273 is obviously 283. So all of those numbers are now plugged in. All right, so now I'll solve. So the natural log here is a button on your calculator. So you'd hit natural log, all right, and it'll open up, most of them will open up parentheses for you, and you need to put these expressions in. So the natural log of this quotient ends up being negative 8.06. All right, and now I'm going to leave this part alone for a moment so I can simplify the difference that's living over here. And 1 over 351 minus 1 over 283 gives me a difference of negative 6.85 E -4. Negative 6.85 E -4. Still in parentheses, because all I've done is simplify. I'm going to leave the negative 8.06 alone for a moment, and I'm going to multiply these times each other. It's easiest to see this way, in my opinion, because we know that fractions multiply straight across. Therefore, I'll get negative 6.85 E -4x across the top, and then 8.314 on the bottom. I'm still looking for the activation energy here, all right? So we can again make the equality be fractional and cross multiply, and we'll get negative 6.85 85 e negative 4x equals, and then go the other direction to get negative 67. Divide to isolate. Now, this is going to naturally spit out joules because that's what the R value is designed to do. All right, so it's going to give me this number on my calculator. It turns out this specific problem requires kilojoules, so I need to slide the decimal to the left 3 times.
Mr. Cummings,
Yeah.
on the
Yeah, I see it. I see it.
what?
What were you going to say?
On the when you sent me it, you sent one of the questions and it said PBO, lead, and then it says which of the following and like choose all correct. That's all you sent me. But
Wait, are you asking me a totally different question right now?
yes, yes.
Dude, you have Ben and Alana in class before it's your turn again.
Okay. And I figured it out actually. Never mind. So good.
All right. Schoology has 0.0 there, so it should be an 8. I need to fix that. But are there any questions, Richard, about that process?
No, are you believing?
I mean, were you able to pinpoint where you were getting stuck, or?
I did.